Hello there, and welcome back to another video. So today we will finish our function block when it comes to our practice uh, in an AI constructed manual for bot development. So last time we covered tasks number 3, 4, and 5, and yeah, and 6. 4, 5, and 6, sorry. So today we will start with task number 7. Let's go. So in here we need to make a function for working with dates. This particular thing was pretty vague to me, so I decided that it would be much better to specify the implementation of that function. So I decided to make up a function that's going to show you how many days and weeks there are left till your next birthday. What do we have over here? We have a function that gets one parameter, which is the birthday. It should be string type. Then it converts it, so it basically parses it from a string into a datetime format. For that, we need to import our datetime module like this. Then we get today, because we need to, count things depending on the current date. And next one, which is not very obvious, we need to evaluate the date of our next birthday. For that, we make our birth date, but replace the year parameter into the same parameter that is in today. So we get current year. But what if our birthday has already been gone in this year? What are we going to do? In this case, so if our birthday has already been in this year, so this date is less than today. In this case, we need to replace the year into the next one. And after that, I guess everything is pretty much clear. We need to count days till our next birthday. You can do it like this. So our next birthday minus today in days. Then to find out how many weeks there are left, we need to divide them without, but not the current just the division. We need to find out how many full weeks there are. Basically, this is what this operator does. And the days is the rest what we have after this function. So and then we print out, so this is my birthday. Let's try it out. Your birthday is in 307 days, which is 43 weeks and 6 days. For example, if there are if my birthday were in May, we would have 31 days, which means 4 weeks and 3 days. I guess this function was pretty fun, and I guess that the explanation is pretty full for such a simple function. The next one is very fun though. We need to make up a function for encrypting the text. So let's try that. What does this function do? In this case, I decided to use one of the simplest like one of the simplest encryptions possible. It's Caesar encryption, which basically gets the ordinal number of the letter we have in the text and replaces with +3, -3, +10, and so on. How are we going to do that? Well, it's not a secret that each character, each letter, has its own unique code in ASCII table, which is ASCII. And if the character is a letter, we use is alpha here, we get our start. So what is the start? Those scopes with the numbers of the letters are different for capital letters and for not capital letters. So we check and say that start will be the ordinal number of a capital if our character is in uppercase, and else our starting point where we are going to count on is the ordinal number of non-capital A. Then we get make our cryptid character, which is going to be start plus order of the character minus start and plus shift. Shift is how much are we going to shift our order. And mod 26, why so? Because our alphabet has only 26 characters, and if it is more than 26, that we should just throw it away and take only the rest, so that it starts all over again, right? Yeah, and then we make it from the ordinal number of the character into the character once again. We append it to our cryptid text, and yes, and if it is not just a letter, we just append it. So and then we return empty string dot join with our list. It's gonna make a new, like, whole new line. Now let's try it without this first of all, and let's see. We have in the land of Mace, in a time of magic, the history of great kingdom lied on the shoulders of the young boy. His name is Merlin. Write down in the comments where it's from. And let's see the result of our function. Oh, look, cryptid. And we see something strange over here, right? So, but what if we implies the same function but with the opposite shift? So by default the shift is 3, and here we use the shift as 3. What if we now use it with -3? Huh? Let's do that. And we have decrypted text. So as you can see, let me just check. Yeah, everything's okay. As you can see, we can decrypt our text with the same function, but just with the opposite shift. Okay, that was task number 8. Now, task number 9. Make up a function for working with exceptions. Exceptions are basically something like errors occurring during different functions and programs. So I decided to make this function as a decorator. Decorator is a type of functions that will alter the behavior will alter or improve or extend the behavior of the inner functions. So I'll explain it a little bit later. We have our function x that works with exceptions, which has the only argument func, which is going to be our functions that we will send to it. We have our inner function wrapper with all the possible arguments, and we try to run our function with all those arguments it can take. And if we fail, we print function, name of the function with the dunder method. Pay attention to this part. Was stopped due to exception, and the exception from the new line. So and we return this inner function. Basically, those names like Roper, arcs, and quarks are conventional. You can alter them, but you know what? No. In this particular case, it's bad to follow the convention. So, to implement our decorator, we need, before the definition of our function, we need to put at and the name of our decorator, which means that inside of this decorator, when we call this function, it will be called this decorator with this function as an argument. And as you can see, we have the simplest possible function over here, def wrong a, return a, right? So it just returns all the arguments it gets. But as you can see, there is only one argument possible. And what if we just try doing it with 2 arguments? Of course, we will have an exception over there, right? Because it's wrong. And what if we don't want such situations to ruin our program? We can handle it with our exception decorator. Let's look at it. And as you can see, function wrong was stopped due to the exception. Wrong takes 1 positional argument, but 2 were given. So it works perfectly. Now number 10. Number 10 could have been interesting and tricky if we haven't already worked with the same particular problem, but just it was not a function. Basically, we need to make up a function for working with a regular expression, so basically with filtering something. And as usual, we have our function which gets the object to filter, and we inside of this function we get an expression variable that's gonna be our filtering expression. The result is going to be list comprehension for all the elements from the original iterable objects we're going to filter, but only if the evaluation of that expression is true, otherwise it wouldn't be here. We have already talked about the eval function and its arguments, so I will not repeat it right here. Just keep in mind that these 2 arguments are necessary for the safety reasons. Okay, and we print result. We can return result if we need it. We can get rid of print result, but it's just more comfortable for me to have all of it here. And we have our primary, which is going to be just the list of numbers from 0 to 29 in range 30, as you can see here. And let's apply this function to this list. And our program asks us to enter the expression to filter. Okay, let's say that we want the list of numbers from 0 to 29, but only those that correspond to the expression number plus 3 equals plus 3 and mod 3 equals to 2. And we have only one number, 2. Okay, let's try that. 2 plus 3 is 5. Yeah. And 5 after the division to 3 gives us 2. Well, we can try something else. For example, x, the division without the rest to 4 is equal to 4. And we have four such numbers because 16 divided by 4 is 4. 17 divided by 4 is 4 with something. 18, 4 with something. 19, 4 with something. But 20 will give us 5. So in here, everything works correctly. So that was our last part of working with functions in this AI manual. And next time we will talk about classes. Of course, we haven't covered everything. For example, there are closures, there are different interesting types of implementation of those closures and generators. We haven't talked about lambda functions, but they're pretty simple, so I will do it a little bit later. And next time we will just start talking about classes and do some tasks. After that, we're going to work with asynchronous programming, which lets us do amazing things when it comes to the performance. And then we will work with files and JSON, which is essential when we come to some kind of, scripting, web development, and so on. After that, we will start working with our bots. So yeah, we'll talk about Telegram, we will talk about Discord. So yeah, then we will have databases, different of them. SQL Alchemy is basically some for working with databases as well. MongoDB as well. And then we will talk about installation of our projects into the remote service. And it's basically will be the, everything we need to become a full-packed specialist. So yeah, you may think that it may take a while, but always remember that even if you are a complete dabbler, you can do it. Just keep pushing. Secret is very simple. So thank you very much for watching this video. Have a nice day.